Hi, my name is Carlos. I'm a full-stack web developer in Portavita, a healthcare company from Netherlands with offices in Innopolis. Portavita provides telemedicine solutions to enhance the prevention, diagnosis, treatment, and monitoring of health conditions. In this video, we are going to cover the following topics: healthcare interoperability, a sample of high-order web components, a sample of Node.js with Express for a POST request, and a basic sample of data persistency with Postgres and JSON-B types for hybrid databases. Healthcare starts with a potential patient. Depending on the doctor, this patient may need some more evaluations from different institutions. For example, a laboratory that will provide some examination and return in some period of time the result. Let's say that this patient will also require a radiography from a hospital with the proper equipment. Each institution will have now some data of this patient. This data will be organized and stored as electronic medical record. And as soon as the results are ready, the patient will be able to return to each of them in order to receive the results and finally the doctor's treatment. This scenario was not efficient and it demanded a time and effort from the patient itself to communicate this data to each of these institutions. We started to consider then the implementation of applications that will not only make the process of communication more efficient, but also provide a more personalized treatment with better and more accurate data for the doctors. These solutions are part of a bigger service called an integrated care system. The data is now an electronic health record. The difference remains in that now the data should consider all the different institutions' data and not just the personal data of the patient itself. These systems require strong security controls and demands implementation of multiple standards. HL7 has been the organization in charge of providing quality standards and guides based on the experience of thousands of medical institutions. The healthcare systems got a history that started in the early 60s, dealing with multiple challenges in patterns of implementation. One of them is semantic interoperability. Semantic interoperability, by definition, is the ability of a computer system to exchange data with ambiguous shared meaning. As mentioned before, the data of each healthcare institution, electronic medical records, are stored and defined according to a specific need. The centralized governance and decentralized data management was not something to consider during the implementation of monolithic systems. Therefore, the communication between healthcare systems and an integrated care system demanded a big effort in maintenance. Today I'm going to share with you part of my experience in the implementation of an actual communication standard called FHIR, Fast Healthcare Interoperability Resources. Also, we are going to see how data persistence is being managed with these resources. FHIR is a standard that describes data formats and elements and an application programming interface for exchanging electronic health records. This represents for healthcare institutions and integrated care systems the opportunity to communicate in the same language. In order to follow this material, you have access to a repository in GitHub. Pause the video, clone the repository with Git, and return when you are done. Currently, one of the most demanded architectures in software is microservices. The following application represents a sample that is going to calculate a simple operation. The same is not supposed to be considered as a production ready, but rather as an educational approach. In order to run all of our services, I will strongly suggest to work under a Linux or Mac environment. We need to have installed in our machine Docker, Docker Compose, and an integrated development environment. Mine will be during this review PHP Storm. The application we are going to review represents a questionnaire that will perform a simple calculation. This application behaves as a microservice and will consider the following scenario. A third party will integrate to our application. Our application will process this data and then give back a response data to the third party. We are not going to store any personal data, only the ID of a patient. The modeled questionnaire will be represented in a user interface with web components made in React. The filled questionnaire will generate a questionnaire response file resource. Then we are going to communicate with our backend architecture in Node.js. The service will generate an observation with the result of our calculation. Finally, we are going to store this data in our Postgres database. To complete the cycle every time the calculation is done, we will return the data to the third party. There are currently available 146 resources, separated in different categories, each of them with different implementation rules. They were tested and they should take care to consider multiple specifications and code systems. The resources we are going to model will be in this case a questionnaire response, an observation, and a bundle. A FHIR resource is modeled in the following way. The mandatory attributes will be the resource type, a unique ID, the status if it's active or not, and the date in which it was originally created. The questionnaire resource will require a title that may serve also as a description for the questionnaire itself, and items that at the same time will contain a unique ID, a code system. Each of the items represents for us a question for our questionnaire application. Display in this case represents a reference of the question to be shown. Finally, the data type as the response this question should expect. There are some other cases in which a question will support a multiple selection question or conditional questions. This can be explored with more details in the questionnaire documentation. The questionnaire response is the message that our questionnaire interface will generate as an output of the questionnaire. It will cover the answers of the questionnaire. It also handles items for this purpose, each of them with a link ID text field which serves as a reference of the question and the answer. The observation resource will be the output message from our calculation service. It will deliver the data inside value quantity. The calculated value and its interpretations reference inside system and code. For this example, the measure system. Derived from will consider the reference of the questionnaire response that was used to process the calculation. These three resources will be later then grouped into a bundle resource. This resource is then used to generate different types of resource groups. For our case, it's a collection. Bundle is a really flexible resource and will not be only used for this purpose, but in order to easily identify who is the owner of this bundle, we may add some metadata. With meta, a tag, and inside the system from where we can obtain information about a patient. Finally, the patient code. Last updated consider the moment in which this resource was created and if needed updated. Entry will contain the three resources that were previously processed. These are ready to be stored in our database and later sent to the system or third party that demands this service. I will assume you already have installed Docker and Docker Compose in your machine and you are currently under a Mac or Linux environment. Let's take a look into our sample. In order to generate our services, we will need to create our Docker images. I created for you a script that will manage this first step. Let's open the console and run. In order to generate our services, we will need to create our Docker images. I created for you a script that will manage this first step. Let's open the console and run. Bash create images. This first step is going to copy our code from the application and the service, deploy and be ready for lib coding. As soon as the images are created, we are going to run the commands docker compose app-d to detach from this process. If all the services are running as expected, we can verify this by running the command docker ps. In our console, our application will be ready with the tag app and the service in the same way. I added in this configuration several utilities and tools that will be useful and helpful for you, not just for this project, but for other of your own. It's open source, so don't worry about reusing them. Let's see what the application is doing and see how this application is managing these resources in order to also provide persistence of our data. Our application will be run in the port 3000. As mentioned before, this will serve as a microservice for a third party. In order to process a patient ID, we will send this data as a parameter in the URL. There are some more steps to consider for security in a production environment in order to control the use of our service, such as tokens authentication and so on. For our example, we will assume we are already in a trusted source and pass this parameter into the URL. Let's say patient equal 123. This application is performing a simple calculation. We just need to provide some data then. Let's say 170 centimeters for the height and 70 kilograms for the weight. 24. The BMI or body mass index is a calculation being used for the doctor to understand if a person has overweight or not. Values above 25 will be considered as obese and less than 18.5 underweight. Now that we know what our application is doing, let's take a look into the code. Let's take a look into the application folder. If you want to create an application with React for your frontend, I strongly recommend you to check the documentation for the React client. It offers a good starting point that should already cover for you the basics. We just need to focus in the source folder. Web Components is part of the different practices for the implementation of the higher order component pattern. The same we'll consider in the following. Each element for your web application will be created and managed in an independent way in order to provide the capability of testing and reusing each of them. I will recommend you to review Atomic Design from Brad Frost, book that is also being published in his website bradfrost.com. I will not go in detail about web components now. The Material React Kit will provide to us several already made components to go straight into the implementation of our business logic. Now let's take a look into the backend code. This is based on Node.js, a Postgres client, and Express.js. Express.js is easy to customize. We have implemented here a single endpoint, BMI calculation, that will perform our calculation, and store it into our database. The Postgres client will let us create on first run the schema and the table of our applications. Our application will then be able to store all the calculated data in our table. There might be some more rows and metadata that a specific case of use will require for a table, but the common rows will always consider a primary key and a foreign key in order to generate a quick relation between tables, in our case, patient ID. Postgres supports a format called JSONB. This let us treat Postgres as a binary database that will store JSON data and will let us perform several kinds of queries just straight into JSON. Let's take a look into pgadmin. This will be located and configured from Docker Compose already for us in the localhost port 8080. The user and password for this sample is just admin. Let's add a new servlet with the name, let's say Innopolis. The connection port can remain as it is, and so on, but we need to focus on the host. The host will be the same as we define in Docker Compose, in this case db Innopolis. The username for this sample is just Innopolis, and the same as the password. If everything is okay, you will be able to communicate from pgadmin to our database, in this case db Innopolis. If we just press double click, we will be able to see what it contains. In order to write a query, we only need to go into our query tool. You just need to press the right click into the database. And inside the query tool, we can start performing our queries. Since we already started to use the database from this application, the patient that we are going to identify easily will be 123. Let's start first checking which information we have in our schema. As we can see inside schemas, we have our schema created called InnoSchema, and inside tables we will identify our FHIR resources table. In order to perform a query, we just need to write select, let's say all the information from the schema and the table that we require. As we can see, these different patients has been already created in the time of testing the application. The one we already created during the video was patient 123. And here we can see all the information that we have stored. As we can see, all the JSON file is stored and it contains the JSONB format. It means that we can perform different kind of queries. For example, let's say that we just want to retrieve, instead of the whole table itself, just one single questionnaire for the patient ID 123. In here we are going to go inside bundle, entry, and pick in the first resource that we understood is our questionnaire. Then match it with our foreign key patient ID. We retrieve now just the questionnaire we needed. Great! You will find much more documentation about queries under JSONB that will become a strong and useful type in order to have a hybrid table that stores data as a relational database and read the data with non-relational capabilities. That is great! I hope you have enjoyed watching this as much as I did by preparing it. We cover with this in full our sample, and we might need to add some more features in order to take it into a production environment, but this will be useful to understand the role of FHIR in applications and a quick overview of technologies such as React.js, Node.js, and Postgres databases, all integrated in one simple Docker Compose file. Continue researching by your own and see you next time. Bye.